Alright guys, welcome back to Underground Science, and in this video we'll be talking about the basics of alkenes. And so I think for the previous 5 or 6 videos we've been talking about alkanes and naming alkanes. And so now let's talk about alkenes. But I feel like once you've got alkanes won't be that hard. So for alkenes, the thing is you have to focus on the suffix "-ene", right? So if we write down alkene here, alright, so let's write down alkene. If you focus on the suffix here, you see the word "-ene", which indicates, okay, we're probably working with double bonds here. All right, so let's write that neater. And so if we jump straight into like an example, right? So if I drew this right here, just like that, based on our previous alkane videos, you would say this is propane, right? Because it's 3 carbons long, there's no double bonds or triple bonds, and it's only a hydrocarbon chain, so you'd say that's propane. But if I changed it to right here, like if I put a double bond there, that would no longer be propane, that would be propene, because we said "-ene" is used when you see double bonds. So it'd still be prop, right? The prefix would still be prop. Why? Because there's still 3 carbons. 1, 2, 3, right? So like remember, at the end of the double bond in a line diagram, those are still carbons. With the brown dots that I drew are still carbons. So it'd still be 3 carbons, so it's still prop. But because now we have a double bond addition right here, right? So since we added a double bond, it would be propene. All right, so this molecule would be propene. And just like that, if you remember in our alkane videos, we went over a huge table, right? And like starting from the beginning, methane, ethane, propane, and so on till like decane, or even further, that you use the same table, except instead of the "-ane", you just write "-ene". So if we look at a table example, right? Now, the reason I wrote methane here is to show you that it's not the same as alkanes, in just if we were talking about methane, right? Because the prefix "meth", as we know, in alkanes and here means 1 carbon, right? But as we know, double bonds, you can't have a double bond with just 1 atom, right? You need 2 atoms to have a double bond at least. So actually you can't really say methane because that's only 1 carbon. So you need 2 carbons at least to have a double bond. Because as we know, like if we drew ethene, right, like this, which would be ethene, these would be hydrogens. And the main bond we have to focus on is the double bond. So we would draw a double bond here, right? That's the least number of carbons we can have in order to use the "-ene" suffix. So that's why there's no methane that we're going to go over when we start talking about alkenes. So this table actually starts from ethene. So let's go here, right, and cross that off. And then from here, it's the same as alkanes, right? Ethene is what? What's the prefix in ethene? Eth. That means 2 carbons. So what would that look like? That would look like this, right? Except that would be ethane. So if it's "-ene", we know we need to add a double bond. So this would be ethene, okay? Same with propene. What's the prefix? Prop, right? Right here. What does that mean? 3 carbons, all right? So let's draw that. 3 carbons long. That would be propane. But we need to add a double bond to make it propene. So you can add a double bond wherever, and that would be propene. Same with butene, right? Let's go over this a few more times. So butene, the prefix is but, that's 4 carbons. So you draw 4 carbons, right? That would be butane, and you add a double bond wherever to make it butene. Okay? Same with pentene. What's the prefix pent? 5 carbons. So 1, 2, 3, 4, 5. But that's pentane. To make it pentene, add a double bond wherever. Okay, and you do the same thing like we did for alkanes, except just add a double bond to make it an "-ene" instead of an "-ane". Alright, so once you do that, so let me go and fill that out, and then we'll come back. Alright, so I went ahead and filled it out, and once you got how to draw these till pentene, you can keep on going easily, right? And so let's talk a little bit more about the basics of alkenes. So if we look at, let's change it to here. If we look at, so remember, if we recall, right? So let's do a recall from our alkane videos. For alkanes, what was the formula that we used in order to come up with an actual formula of a compound really quick? We had CN H2N plus 2, where N, right, what did N equal? The number of carbons, okay? So to go over this, if we had propane and someone asked you the formula for it, you'd use this formula, and you look at the prefix pro, that's 3 carbons, so you'd feed that into N, so that'd be C3H2 times 3 plus 2, which would be C3H8, right? But we're talking about alkenes, so there's also a formula you can use for alkenes, and that would be CnH2n. So it's, less math than alkanes. So if you were to look at butene, right, and someone said, all right, give me the formula, right, come up with the formula of butene. You'd do the same thing. Look at the prefix but. What is that? 4 carbons, right? So feed that into N. So N is still the number of carbons, okay? Feed that into N, so you'd get C4H4 times 2 is 8, right? So C4H8. That's the formula for butene. So if we did one more really quick, right, without the equation, so hopefully you got it. So like if we went over pentene, the prefix pent is 5 carbons, right? So that would be C5H2 times 5, which is 10. So the formula for pentene would be C5H10. And you can do that for any alkene. But the thing is, what if you don't know the formula CnH2n? Can you still come up with this? And the answer is yes, right? So if I said, all right, give me the formula for, or give me the formula of the compound for hexene, right? And so if we look at the prefix hex, that's 6 carbons. So if you just draw that out, 1, 2, 3, 4, 5, 6, right? So remember, in a line diagram, these points are carbons, even though it's not shown. And then you have imaginary hydrogens also in order for this carbon to add up to 4 bonds. So 1, 2, 3, those would be hydrogens. And this bond is to this carbon, so that's 4 in total. And you do that for every carbon, because carbon, right, can have up to 4 bonds according to octet rule. Okay, so if we look at hexene, and if we draw another one right here, if we just go to another page and draw hexene, 1, 2, 3, 4, 5, 6, right? So that would be hexane, but we want the formula for hexene without using this formula. Okay, so without using this formula, how do we find out the formula for hexene? So to make it ene, add a double bond anywhere. So let's just choose random here, right? Now, just fill in the hydrogens according to the octet rule. So remember, carbon can have up to 4 bonds. So let's start with this carbon and work our way that way. So for this carbon, it already has 1 bond, right, to this bond right here, to this carbon. So you need 3 more hydrogens in order to add up to 4. So 1, 2, 3. And we won't actually write the hydrogens in, right, for the sake of time, but the orange lines are bonding to hydrogens, right? So let's keep on going. So this carbon right here would be bound to 2 hydrogens because it already has 2 other bonds to carbons. So in total, that would be 4. And then I think you've got the pattern. So this would be 2. Now here, this carbon has 3 bonds, right, already. So it can only have 1 more bond. And why does it have 3? Because a double bond counts as 2 bonds. So it'd be 1, 2, 3, and then it needs 1 more bond to hydrogen in order to fulfill the 4 bond octet rule, right? So we would just draw another bond to hydrogen, and then this carbon, same thing. It's bound 3 times. 1, 2, so that's 2 bonds for this double bond, and then 3. So we need 1 more to fulfill the octet rule, right? And then this carbon, of course, the last carbon only has 1 bond, so we need 3 more. All right, and that's it. So the orange lines, for us, right, the orange lines, we know it's about binding to hydrogen, but we're not going to write that in for the sake of time. So let's just count it up. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So remember, that's hydrogens. So that's 12 hydrogens. And because the prefix is hex, right, we drew 6 carbons. So that's the formula, C6H12. So you didn't have to use this formula to figure out this equation, but you can check it. So how many carbons are there? 6. So C6, and then H2 times 6 is 12. So that's the same thing. So that's basically it for alkenes, and then just like a good intro, and then starting the next video, we'll start actually naming alkenes and doing practice problems relating to that. Alright, so I'll see you guys in the next video.